Welcome back, gentlemen. A new video, new topic, and this topic I am sure is going to be of great excitement for all the people going for exams. Yes, the topic is going to be Safematic steering gear, which deals with the automatic isolation procedure of a steering gear. Having said that, this video presumes that you have seen all the previous videos on steering gear. So if you are not done so, please jump there, have a quick look, and then come back because this is going to take off from all those. Knowledge base of the previous videos. Having said that, in this video we are not going to go deep into the relationship between autopilot and the steering gear. We'll stick just to the basics of automatic isolation system of a steering gear for a 4-ram steering gear circuit. You're watching Chief Engineer's Tea Time Talk. I'm Ramesh, the anchor who will guide you through this channel, and I hope you find this topic very useful, enjoyable, and you really enjoy this video. Thank you so much. Take care. Bye.
Well, the takeoff point for this video is from the point which we covered in the previous videos. In this video, we are going to discuss only the Safematic concept as required for class 4 and class 2 exams. This knowledge of course is not enough for chief engineer who needs to understand the concept and working of the torque motor and control of the variable delivery pump and the relationships with the autopilot. In this video, we will not get into the controls of the pumps. Here you see system 1 operating rams 1 and 2. The system is using a variable delivery pump. The operating details etc. were covered in the previous videos. Now let us add a facility to make it unload and load as per our requirement. So here you see the component. Let's assume we are idling as there is no requirement to move the rams. You can see that the 2-position direction control valve, which we will call UL1, is connecting both the sides of the pump. So we say it is recirculating. Now suppose we want to move the rudder. We need to allow the oil to reach the rams. We put this 2-position valve in load condition. You can see that here. So the pump goes on stroke and the oil reaches the rams. This is the basic stuff, obvious. Very similar to this, we are going to have a system 2 for redundancy. Here you can see system 2. Correct? So this system 2 is able to operate rams 3 and 4, but at the moment it is showing in idling our recirculating condition. Now suppose we want to operate all 4 rams with pump number 1, which is loaded. We need to make an arrangement to make that happen. So here you see another set of 2-position valves. Let us call it IB1 and IB2. You can see that the oil reaches the other set of rams, namely 3 and 4, through IB2. IB1 and IB2 are there to enable both the pumps 1 and 2 to be able to supply to all the rams. They are in fact cross connecting them. At the moment, let us call these as isolation valves. The logic we use here is if it is not cross connecting, it is isolating the systems. Let's move to automatic isolation concept and operation. Here you can see that pump number 1 is operating all 4 rams. This is usually the case when the ship is en route during a sea voyage. In this case, pump 2 is off. Now if suppose there is a leak. Well, the leak can be in system 1 or in system 2, we don't know. Wherever be the leak, the first thing that would happen is the occurrence of an alarm. Say alarm 1. Alarm 1 does not result in any additional activity. One just needs to top up oil. So let us treat this as an operational low level alarm. But suppose the alarm was triggered because of a major leak or rupture in the pipes. The drop in oil level will trigger alarm 2. Now this alarm 2 will now isolate system number 2 completely by operation of the isolating valves IB1 and ensure that number 1 pump supplies only to cylinders 1 and 2. Pump number 2 of course is lined up to cylinder 3 and 4 by default. But it is off. Now let's say leak was in system 2. The oil level will not further reduce and the system will continue as it is. That is, pump number 1 will be operating with cylinders 1 and 2 and all is stable. Nothing more is going to happen because the leak was in system 2 and it is got anyway isolated. But we also need to remember that since the cross set is common, the cylinders 3 and 4 will also be moving. So if you do not give a path for the exhausting cylinder to recirculate, then it will create a hydraulic lock and number 1 pump will not be able to move cylinders 1 and 2 also. So we need to create an arrangement called recirculating or bypass arrangement. Here you can see that the cylinders 3 and 4 are able to recirculate amongst themselves through isolating and bypass valves IB1 and IB2. The system stabilizes in this arrangement without loss of steering. If the leak was in system 1, then oil level will fall and alarm 3 will get generated. This will result in a change of pumps. Pump number 2 will be started, put on load, and pump number 1 will be cut off. You can also see that now pump number 2 is operating cylinders 3 and 4, and cylinders 1 and 2 will be recirculating through the isolating and bypass valve IB2. There may be small variations with some makers where pump number 2 will be started to operate cylinders 3 and 4 simultaneously when alarm 2 itself is activated, but without the IB2 valve in isolating position. Hope you enjoyed this video and found it very useful. See you in the next video. Thank you so much.